AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Our host brings you the leading minds in AI, sharing their story, their success, and their advice. Focusing on fast-tracking you to the top, AI in Action cuts through the hype to help you kickstart your data science career. To listen to the latest AI in Action podcast, head over to www.alldus.com/podcast or subscribe via iTunes, Stitcher, or Google Podcasts.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is David Kuntz. David is the head of data science for Degreed. David, welcome to the show.
Hi, JP. Thank you so much. Really appreciate being here.
Not at all. Our pleasure. So if you wouldn't mind, please start by giving us a little bit of background of yourself, what got you involved in technology, and your journey with some of the roles you've held along the way.
You know, it's sort of a funny story because when I was a kid, originally I wanted to be a microbiologist. And that led me into wanting to be, for a time, something entirely different. I wanted to grow up to be Bruce Lee. And that obviously didn't happen. You know, at another point, I wanted to be so many different things. Never wanted to be an astronaut, but I did want to be a genetic engineer, and that's what I went off to college to study. But it turned out that what was involved in that was not actually something that I was particularly excited by or particularly skilled in. And I ended up more or less arbitrarily getting a degree in philosophy instead. I studied epistemology, which is theory of knowledge, which is really about what is knowledge, what is belief, how does belief become knowledge, what counts as evidence for the things that we believe, and how much evidence do you need in order for it to be something that you know. And I thought that was pretty interesting. Everyone told me there are no jobs in philosophy. But I pushed ahead, went into graduate school to get a PhD in philosophy and discovered everybody was right. There were no jobs in philosophy. So during graduate school, I had earned a little money on the side writing software. And I thought, you know what, I'm gonna write software. I don't have a degree in that, but I'm sure I can find something. So I was heading out into that world to look for jobs in computer science. And I came across an ad that was run one day in one publication that said philosophers wanted. And so I thought, how can I not apply for this job? Turned out that was the company that makes the law school admission test. And they were having some challenges at the time and were looking to hire a new breed of test developer to make the test. And I was their first hire of that new crew. And my job was to figure out what reading comprehension was and what analytical reasoning was and how you would measure it, how you would identify these skills in people and turn them and measure the degree to which they had them and could apply them. Now, this was a job that I felt very bad about taking because I was convinced that large-scale standardized tests measured nothing more than one's ability to take large-scale standardized tests. And, you know, by and large, many of them are not that great. But along the way, I discovered that there was this branch of statistics called psychometrics, which is really about measuring things that are going on in people's heads, identifying what constitutes evidence for the having of a skill or an ability to some degree, and how you actually use data to make those inferences. And so the bulk of my career has really been about how you leverage technology and data in the service of better measurement, better teaching, and better learning. Here's the funny thing. This career that I had was a total accident, right? I mean, it was entirely because I didn't feel like being a genetic engineer, and I happened to see this ad. I happened to decide to study philosophy, and I happened to see this ad one day. That's led me to the role that I have now at Degreed as the head of data science.
It's quite an interesting journey with a couple of ideas of what you thought you may become, but unsurprising, like a lot of people who end up in senior leadership roles within data and AI, it's timing, luck, and just following your curiosity, which can often lead you into some amazing positions. So now focusing on your current role, for anyone who's not previously heard of Degreed, could you give us some insight into what the business does and what your role as head of data science involves?
Absolutely. So Degreed is a 7 or 8-year-old startup in the learning experience space, right? We've developed a learning experience platform that at present has 3+ million active users on it. Generally, these users are employees of large companies. Many of our clients are in the Fortune 100, Fortune 50. It provides a means of sort of aggregating the learning opportunities for learners using the platform. A company who would use a platform like this often has multiple sources of learning materials that they make available to their employees. Some of them are third-party subscriptions. For example, they may subscribe to LinkedIn Learning or to Coursera or to other providers of rich learning content to make available for their employees. A lot of the content is home developed around particular areas of interest to the particular industries of these clients. And so they may have very specialized content about how to deal with particular kinds of situations, all the way to very sort of generic content about leadership training or how to become a better manager or things like that. And so one of the things that we do is we aggregate all of that content, plus our own content as well, into the system, so that employees have a sort of one-stop shop, one place that they go to, single sign-on into it, and all of their learning materials are there. On top of that, we provide them with a view into their own skills that they may not have had sort of laid out in front of them before. They get the opportunity to tell us about their skills and to have their skills evaluated so that they can better understand sort of what it is that that they're ready to do next, what skills they really need for their current role, what skills they might want to learn for roles that they're interested in, and so on. And so that then enables us to provide, on top of that, a view for the company writ large about the skills and the skill distributions across their organization, which helps our clients plan for the future. They know that their industry is moving in a particular direction, and so they can project that their skill profiles that they're going to need over the next 5 or 10 years are going to change. And so through the Degreed platform, they can start to offer learning experiences to their employees to help drive the next generation of skills growth within their organization.
Quite an exciting offering for organizations, as you said, who are looking to leverage the various different trainings and education platforms available. Focusing on the data science aspect, what happens behind the scenes, can you give us some insight into what you're being tasked with, some of the problems you're going to be solving, some of the exciting projects down the line, and what drew you to this challenge at this point in your career?
Well, Degreed, ironically enough, represents a solution in many respects to the problem that I had in trying to figure out what I was going to do with my life. As I said, I got into this whole sort of data science track accidentally. And part of what we are trying to enable is a means for individuals to make more considered and purposeful decisions about where to invest their time and what opportunities are available for them. One of the things that we all as humans are sort of bounded by our own experience. We don't know what we don't know. And part of what the Degreed platform tries to do is to surface things to individuals, very personalized, that that can open doors for them and open horizons for them. They may not have known, for example, that their skills were by and large a very good match for this other set of opportunities, just as my skills turned out to be a very good match for the path that I took to get here. So the data science challenges that underlie that are pretty substantial. Not only is there the challenge of making the sort of ordinary inferences about what someone knows and what they're good at, which has a whole host of unsolved problems associated with it. But in addition, there's a great deal of inference that has to happen around both what is a skill and how do those skills relate to job roles and job descriptions and career paths, and how does one deal with the fact that no two organizations have the same sort of understanding, underlying understanding of what skills, what collection of skills are most required or most appropriate for a particular job role within their organization. So there's a lot of data science work that we're engaged in looking across jobs and job descriptions and skills and analysis of skills to put together a sort of robust underlying metadata structure that will enable those inferences sort of in near real time or real time across all of these different kinds of environments.
So quite a complex challenge. Could you give some insight into how you're using machine learning and data science to move the projects along, and where you see this evolving as you build out your data science team?
Absolutely. So the first order of business for us is really right now getting the right infrastructure in place to do sort of real-time online processing. We haven't historically had a need to do that, but our growth has been such that now that's becoming a really important part of our product offering and our platform. And there's no rocket science to that anymore, right? Companies have by and large figured out how to build those kinds of pipelines and frameworks. The more interesting set of work that we really have in front of us, as I mentioned, is starting to develop models that will do a few different things. So first off, let me just touch on this whole notion of proficiency estimation for a minute, right? Understanding a learner's proficiency, their degree to which they are able to do something, is straightforward when you can ask them lots of questions. That's the whole basis for sort of assessment. Learners in organizations aren't always in a position to be able to answer lots of questions. That is, they have their day jobs, they have work. And so part of what we are trying to figure out is how to leverage episodic, small collections of data over extended periods of time to build a reliable skills picture of each learner, so that we can then personalize the offerings that we recommend to them. One of the important things there to recognize is that recommendations in the learning space are sort of substantially different from the kinds of recommendations that one would make in a retail space. Retail recommendations are the ones that we're almost familiar with. But in the learning space, what's really important is that, in fact, if I recommend something to you, JP, that I want you to spend time on, or that my system wants you to spend time on in order to learn some skill, that activity really actually needs to be something that is likely to help you learn that skill, right? I can't give you, I'll give you an example. I came across an article recently about IBM's use of artificial intelligence in the HR space, right? And the article was interesting because there was this whole ironic sort of component to it. IBM also at the same time laying off 30% of their HR staff. because of the AI that they had developed. Here's the thing. So on some level, this is an article about artificial intelligence, but it is not an article that, if I gave it to you, is going to teach you anything that would enable you to improve your skills in the AI space, right? Rather, it is an article that will help you understand something about the social aspects of artificial intelligence, and it will help you understand something about the social impact of artificial intelligence, but it's not going to help you improve your skills in developing artificial intelligence. So part of the data science challenge that we have in front of us as well is to really try and identify what the content is about in a way that lets us identify whether this piece of content is actually going to help you as a learner and as a practitioner improve your skills in this area.
Quite interesting. Talking then about the growth of your team and what's in store. You mentioned, look, you guys are 7-8 years in business. You've recently taken on the responsibility for driving all data science. As the team grows and as the project pipeline evolves, where do you see needs within your group arising, and what type of profiles stand out to you as you build a data science team specifically for the grid?
That's a great question, JP. So I built a lot of data science teams in my career. And one of the things that I look for is to build a diverse team of talent and experience. I have found that having people who have tried a lot of things, who have touched on a lot of things, who have had experiences in a lot of different areas, bringing them all together ends up creating a team of people who can bring different perspectives and drive better solutions. So as an example, I look for people who have had experience in different industries. Happily build a team with some people who have, for example, bioinformatics experience, gene sequencing kinds of problems that they're looking at, bundled with some people who have spent some time in computer vision, tied in with some folks who have done a bunch of NLP work, and add that to folks whose strengths are on building scalable machine learning models, for high volume, high throughput, real-time systems. You bring all of these people together and they can start to play off one another in some very exciting ways, saying, oh, well, we tried this technique in this context. Maybe it'll work in this new context. Oh, I've never heard about that. Tell me about how that works. Oh, that's like this other thing. Yeah, we could do this stuff together. So when I try and put together a team, I look for this diverse mixture, because these are the teams that I've found that are most likely to be most successful in solving some of these kinds of challenges.
You've talked previously about some of the teams you've built along the way, and prior to your role in Degreed, you've obviously led other data science groups. So could you give us some insight into what you've learned along the way and what you've enjoyed most about transitioning from philosophy into now pure, heavy, detailed data science and machine learning?
It's funny. The paths that we take in our careers can be sort of remarkably useful along the way. One of the things that some former colleagues of mine developed many years ago was this model called, or methodology rather, called evidence-centered design, in the context of building better assessments of people's knowledge and skills. Evidence-centered design is an approach that I then have modified over the years to leverage in the context of data science. It basically flips things on its head from the way data science projects and assessments are often built. A data science project that is evidence-centered design based starts with the claims that we want to make. What are the things that we want to be able to say about the outputs of the models that we're developing? What are the claims that we are making? Are we making a claim about the likelihood that a particular person will do a particular thing? Are we making a claim about the likelihood of a particular event being of a particular type? Or are we making a claim about some relationship between an object and some other object? There are lots of different ways that data science projects can be sort of described and framed. But if you start with the claims, then you can ask a really important question, which is, what would count as evidence for those claims? If you never ask the question, what counts as evidence, it's hard to put together a robust model. From there, you can say, okay, so I know what the claims are that I want to make. I know what will count as evidence for that. Now, let's think about the things that we can put in place that will actually collect that evidence. And then from there, you can then actually start to build the particular mechanisms in the product or in the data ingestion system that will let you extract the things that count as evidence to act as appropriate inputs into your model that can then be used to make the inferences that are in fact those claims, right? And if you do that, if you start by building it sort of backwards in that way, that enables you sort of at every point along the way to create tests for whether or not your model is working. Because you need to be able to ask sort of all the way through, how am I going to know if this thing is actually working and making a difference?
It's such an important point that is often lost, particularly on people making the transition from academia to industry. Understanding that you can't just fall down the rabbit hole of pure research that has to be a deliverable and a value add to a business. So it'd be great to hear some tips and pointers and some advice on how junior data scientists, machine learning engineers can start to adopt that methodology to prevent themselves from falling into that rabbit hole.
One thing that you have to be able to do is sort of understand what the base case is before you sort of head down the path. I'll give you a sort of trivial example of that. I was chatting with someone just the other day, and they were talking sort of excitedly about a project that they had worked on in school. They were trying to build a model to determine whether an NBA player would return the next year. What proportion of NBA players would return, right? And they were very excited because they said prediction accuracy 80%. And I said, okay, well, what proportion of NBA players return every year? And they said, I don't know. And I said, so that means you don't know whether or not your model is actually doing better or worse than a sort of nominal model that just predicts that every player is going to return. If it turns out that 90% of the players return every year, the best model that you could put together, or the easiest model that you could put together, would be one that says every player returns. And then your prediction accuracy will be 90%. And he said, oh, I never thought of that, right? This is one of the really critical things, and one of the things that I've seen time and time again with people who are just getting into the data science arena, is that they haven't had the opportunity or the thought to kind of step back and say, what does that world that I'm trying to model actually look like, right? And evidence-centered design can help them do that.
I think that's really helpful, and I'm sure people will start to focus on that as they advance their own problem-solving capabilities. Final question. It would be good to focus on what you've learned along the way. You've held quite a few different interesting roles, now landed in a position where you're leading all data science operations for a very exciting organization. What advice can you offer to aspiring data scientists or people who are considering data science, machine learning as a career? Data
matters. This is a thing that I've seen over and over again, is that a company that you work for, or a company that you think you want to start, has great ideas about how they can use machine learning, data science to do something magical. And yet they will build an application or they will build a system, or they will build a product that doesn't actually collect the data that you need in order to do those magical things. Happens over and over and over again. And it doesn't happen out of any ill will. It doesn't happen out of stupidity. It doesn't happen out of any of those reasons. It just happens because often the people who are in the roles that are making the decisions about how to build the product don't understand how data fits into the equation. So one of the pieces of advice that I would love to offer, that I would love to see more of, is in two directions. One is to the product side of the house, and the other is to the data science side of the house. On the data science side of the house, as an up-and-coming data scientist, you can make a huge difference by helping your organization understand really what's needed, how these kinds of inferences happen in a very sort of straightforward, non-mathematical way. Help them understand why it matters that you collect this bit of data in this way, why it should be time-stamped, right, as opposed to just overwritten, right, with each new update. Help them understand how those kinds of details can make a difference in the sort of miraculous things that you can help enable them to do. And on the product side, be open to listening to your data scientists, but not just be open to listening to them, but actively solicit their opinion early on in the development of these products and services. Because at the end of the day, if you don't have the data to do the things that you need to do, you won't be able to do them.
I think that's some really important piece of advice, because the relationship between both sides is what drives the overall productivity and the end result. David, this has been incredibly enjoyable. Thank you so much for your time. David Kuntz from The Grid. You've been listening to AI in Action.
AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Alldus offer an exec search program. Alldus can help you discover how data science and AI can transform your company. With our unrivaled network of C-suite executives and senior AI professionals, we offer retained search services across the US and Europe. Get the Alldus advantage. Become a member of the Alldus community and enjoy some of the following: AI meetups. Once a month, our community gathers to listen to some of the leading experts in the world of data science and AI. Our speakers come from all over the world, including Dublin, Boston, and Frankfurt. We also have our AI mentors. Our experts will provide mentoring to Alldus members. And don't forget our AI in Action podcast. Each week we have guests from all over the world talking us through their education, career, and more. Become an Alldus member and get the Alldus advantage. For more information and to sign up for our newsletter, log on to www.alldus.com. That's www.alldus.com. Alldus International, empowering through AI.